best way to expand a binomial that's being raised to a power, right? So it's really like doing multiplication but not having to multiply it 5 times. So that's what Pascal's triangle is. But then we also, I talked about like on that homework, you added and subtracted polynomials, which was just combining the like terms. You multiplied polynomials back on that homework. I think it was like page 170, where you just distributed to each term. Okay, but we skipped over dividing polynomials, so we're going to do that today. Now, I'm going to go through 2 different ways to divide polynomials. One of them is long division. Do you remember the good old days? What grade do you think you were in when you did long division for the first time? 4th, 5th grade, something like that, maybe? 3rd grade? It's hard to say. Okay, so I'm going to take a little trip down memory lane and do some dividing of polynomials, or dividing of long division with regular numbers, and then we'll divide the polynomial. Now, I really like long division for polynomials because it like kind of makes sense based on how you used to divide things. Like the answer, the work, it sort of makes sense. The other method that I'm going to teach you is something called synthetic division. Think about things that are synthetic. They are fake, right? Man-made. So, I mean, it isn't necessarily fake division because it works, but it sort of takes out all of the meaning. It's just like a quick way to divide the polynomials, so we love it, and you're going to want to know how to do synthetic division, but it doesn't really feel like you're dividing polynomials. So we're going to see both methods, okay? Okay, let's start. I'm actually going to change this number because I did this first hour, and I'm going to change this. Let's change this to be 1,759. And you can decide if you want to write this down or you just want to pay attention. Either one is fine with me. Okay, if you wanted to do 1,759 divided by 3, you put 1,759 in the division box, right? That's called the dividend, the thing that you're dividing. And then you put the 3 on the outside. That's called your divisor. And then back when you first learned about long division, you maybe started with like, okay, so I start with the first terms here. Like, how many times does 3 go into 1? It doesn't, right? It's not big enough, 1. So then you go out to the hundreds digits right here, and you say, well, how many times does 3 go into 17? More than 2. 5. Okay? So we'll put a 5 above that. So we were like, look, we couldn't divide the thousands, the 1,000 by 3, because 1 wasn't big enough. So we went out to the hundreds, and then when we did the 17 divided by 5, you see how we lined it up? We put it in over the 7. Okay, and then what do you do with this 5? Multiply by 3 and get 15. That goes underneath. What do you do with these 2 numbers? Subtract them. So 17 minus 15 is 2. Okay, we're going to be doing that same thing with polynomials. We're going to figure out, like, okay, what is that thing? Like, how many times can we get it in? I'm going to phrase it differently in a polynomial because it's not a number, it's a variable. Like, okay, we're going to figure out what that is. We're going to put that thing on the top. We're going to line it up real nice with whatever we were dividing by. And then we're going to do 5 times 3. We're going to do the multiplication, and then we're going to subtract. So you're going to see the same steps. And then what do you do after you subtract and get 2 right there? You done? Bring the 5 down, so we're going to see that too. We're going to bring down a term in our polynomial, so we bring down the 5, and then we just repeat the process, right? How many times does 3 go into 25? 8. 8 times 3 is 24, so we do the multiplication. We're going to do that again, and then always subtract and get 1. Bring down the next number, so that's 19, and then repeat, okay? So how many times does 3 go into 19? 6. Now, do you agree, like, you know you're at your end of your division because you've hit the end of the division bar, like you've lined up the ones? Okay, so you get 6 times 3 is 18. What does that mean this 1 is? That's your remainder. Okay, let's talk back, trip down memory lane. What did you used to do with the remainders? Austin? Okay, you could put a decimal, add a 0, bring to 0, and keep going, and then you have a decimal in your answer. Okay, so that's one thing we could do. What else did you do with the remainders? You raising your hand, Zach? Oh, those were the best days, weren't they? R1. Remainder 1. I love that. Okay, so we used to just say R something. What else did you do with the remainder? R, decimal, probably everybody's favorite, fraction. Okay. So we used to take this remainder. We're going to do more of the fraction thing with our polynomial. We used to take this remainder and put it over 3, the divisor. Right? This is 586 1/3. You have 1 left over, so you don't have a whole, you just have a third because you couldn't divide 1 by 3. And if we did Austin's method with the decimal, we would put the 0 in there, and then we would get a 0.3, and then we would do it again and add another 0. We would get 0.3 repeating, wouldn't we, which is 1/3. All right. Okay, so let's set up long division the same way. X squared plus 7x minus 2. And we're going to divide by x minus 2. So the dividend goes inside the thing that I'm dividing. That should be the bigger polynomial, the one with the greater degree, or they could have equal degrees and we could divide them. But you won't really ever divide polynomials with smaller degrees by bigger degrees. One thing that you're going to see on my next example is this one that's underneath the division bar. You got to make sure it has all its terms. So like, what's the degree of that polynomial? 2. It's the highest exponent. So you have to make sure it has every x that's less than 2. So it has to have an x squared, it has to have an x to the first, and then you have to have your like constant term. That's the x to the 0. If it's missing any of those terms, you got to put a 0 placeholder for it. Because you need to be able to like line things up with their like terms. Okay. So when you start dividing polynomials, here's the thing. You see all those terms, you get a little bit nervous. Like, how am I supposed to divide all those x's and all those numbers, right? So you don't do everything. You just look at the first terms. Okay, so I always underline them. I'm going to start with x squared, and I'm going to divide it by x. Well, what's x squared divided by x? X. So x is the first number. Instead of saying like how many times does x go into x squared, that's kind of like a different way, like it doesn't really flow as nicely for this one, but it's like what would I have to multiply x by to be x squared, and the answer is x. Okay. Now, when you say x, the thing that you want to make sure is that you line it up with its like term so that you'll know when you're done with division. So we're going to put it above the 7x. So put an x up there. Okay. What do we normally do with those numbers we put up in long division? Multiply them by our divisor, right? In this case, we'll have to multiply it by the x, and we'll have to multiply it by the -2. We got to distribute it. So we have 2 terms. So down below, I'm going to get an x squared minus 2x. Is everybody okay with what I've done so far? All right, now what do you normally do with these things back when they were numbers? You subtract them. Now you have to be careful here in a polynomial because I want to subtract all of the red terms, right? And when I say all of something in math, it would be like they were protected by a set of parentheses, or you could think about because it's got more than one term, you got to distribute your negatives. So what I always do on this one is I know I want to subtract this line, so I just got to change all the signs through that whole line. So this is going to be a minus x squared, and this is going to be a plus 2x. Okay, that's tough. That's an easy place to make a mistake. A lot of people minus x squared, but they don't change the sign of the 2x or the negative 2x. All right, well, what happens to x squared minus x squared? Gone, right? That's what we want to have happen. If you pick a number and then you do your multiplication and then you start subtracting and that first term doesn't cancel, then you didn't divide, you pick the correct number at the top. It should cancel. This one won't always cancel. 7x plus 2x is 9x. Bring down the next term. Restart the whole thing. Don't worry about everything. Only worry about the first term. So what's 9x divided by x? 9, and that's a positive 9, right? So I'm going to put a plus 9. Multiply by the divisor. So that's going to be 9 times x and 9 times negative 2. That's 9x minus 18. What am I really doing? Subtracting. I'm going to subtract everything on that line, so I'm going to change all the signs. Negative, positive. 9x minus 9x is gone. Negative 2 plus 18 is 16. Well, now I'm at the end of the division, right? So that means that this is the remainder. And we're going to do like we did over here. We took the remainder over the divisor. One like little change here is this is supposed to be kind of like a polynomial, although now my answer isn't a polynomial because I'm going to be dividing by x. But you should separate each term by a plus or minus. So instead of just saying like 16 over x minus 2, it's going to be plus 16 over x minus 2. Divided the polynomial. Okay, so that's your answer. It doesn't look very nice, does it? I don't like it when they have remainders. But I don't like it when my other division has remainders either. That bothers me because it's a fraction or a decimal. Okay. Before I go on, I'm going to talk about like what this actually means. Okay. Do you agree that like what we're saying is like if we multiply these things together, we would get 3 times 586 and 1/3, that we would get 1,759. Okay? So what we're saying over here in polynomials, if I take this binomial x minus 2 and I multiply it by this whole expression, I will get x squared plus 7x minus 2. You don't have to do this. Okay? I'm just going to show this. Okay? So x minus 2 times, what was my answer? X plus 9 plus 16 over x minus 2. Is that right? Okay. If I multiply those things together, I should get x squared plus 7x minus 2. Okay. I'm going to do my distribution a little bit different here, okay, than I normally do. Normally I would take one term at a time and distribute. Now I'm going to distribute all of x minus 2. So if I take x minus 2 times x, I can write it out like that. And if I take x minus 2 times 9, I can write it like that, right? I'm just distributing that whole group of parentheses, so I will have to distribute here in a minute. But what happens when I take x minus 2 times 16 over x minus 2? the x minus 2's would cancel, and it would just be plus 16. Okay. So then I get x squared minus 2x plus 9x minus 18 and a plus 16. That's x squared plus 7x minus 2. Is that what we said? Yeah, that was the problem. So it's just saying that, like, when you divide, if you were to multiply these two things back together, you would get that polynomial that you had started with. Okay, let's do another long division. Then I'll teach you synthetic. Okay, just glance up here at the board for me. What's the degree of your dividend, the thing you are dividing? 3. What's a concern you might have about that polynomial? There is no x squared term, but what if I need a place for x squared in my division problem, right? So if you're missing a term, it's degree 3, I have to have all the terms below it. If you're missing a term, put a 0 placeholder there. So when I copy in my dividend, the thing I'm dividing, I'm going to start with x cubed, that's my highest exponent. Since there is no x squared, I have 0 of them. And then I have minus 8x plus 3. That way I have every single term going down. Okay, let's divide by x plus 3. Okay, see if you can work like just a little bit ahead of me on the board, right? So what are you going to do first? How many times can x go into x cubed, which is kind of a weird question, isn't it? Because it's like, well, x cubed. But think about it like sort of the reverse. What's x cubed divided by x? X squared. Or like, what do you need to multiply x by to be x cubed? Is another way you could ask that question. It's kind of weird. Okay.
So, for the squared,
Mm-hmm. Okay. So, like, do you see now why it's important I put the 0 there? Because the first term, x cubed divided by x, gives me an x squared. And if I didn't have that, where would I have put my x squared? Like, how would I really know when I finished my long division? I need a place for it. Okay, if you're working ahead, did you get x cubed plus 3x squared? Did you remember to distribute? So you're doing x squared times x and x squared times 3. And what are you really doing? Subtracting both of those. So they both turn into negatives. This first term should always cancel. That's part of the division process with the polynomials. This is going to go away, and then I have negative 3x squared. Can you double check that you have a negative, not a positive? Bring down the next term, minus 8x. Restart. So I always just ask the question, what's this first term, negative 3x squared, divided by x? Negative 3x. Distribute negative 3x times x is negative 3x squared. You want them to be exactly the same, so that when you subtract them, they turn into opposites.
Where did you get 3x again?
I so I can't worry about everything, so I only look at the first terms. So negative 3x squared divided by x. And distribute the negative 3x to the 3 over there. That would be what? Minus 9x? But remember, you're really subtracting the second line, so change them to positives. Okay, it's minus all of that. And minus all of that would be distributing my negative. Don't just subtract the first term, you gotta subtract the second term. And then I get a 1x, thank you. Bring down my plus 3. Oh, you see what's happening here? Now, what I have left over, x plus 3, is the thing that is the divisor. So, x divided by x is 1. I'm going to put a plus 1. I'm going to distribute it. That's x plus 3. But I'm really subtracting both of those. So, what's my remainder? Don't have one, so I like that. That makes me happy. I'll put a smiley face in my 0 remainders because I feel good. So this one works out really nicely. If I did x plus 3 times x squared minus 3x plus 1, distribute all the terms, combine the like terms, it would go back to being x cubed minus 8x plus 3. Those we could describe, those are factors of the polynomial. Because when something has a 0 remainder, it's a factor. Like if I ask you, what are the factors of 15? 1 and 15, 3 and 5, because they divide nicely. 2 is not a factor of 15 because it has a remainder. Okay, questions anywhere on my long division? Okay, now I'm going to teach you synthetic. Okay. So like we kind of see what's happening with our x terms. Synthetic is going to take all the x's away, so it doesn't really like have the same meaning as long division. We're going to learn a new setup. But I think you're going to find that you really like synthetic division. So if you can do synthetic division, a lot of us are really going to like it. Okay, so I'm going to do the same 2 problems, but I'm going to do them synthetically. So I have my long division over on the side. Okay, so instead of having like our regular division box, synthetic division, I say it looks like a long L. If you're using your notebook paper, you want to have 2 lines and then a line. So it's like 3 lines high. Okay, a line, a line, a line. Okay, inside the synthetic box, on the top line, you put the coefficients to all of the x terms. And same rules apply. If one of the terms is missing, you have to put a 0, right? Okay, so what's the highest exponent in this one? 2. So I have to have an x squared, an x, and then a constant term. What's the coefficient to x squared? 1. What's the coefficient to your x? 7. What's the coefficient, or what is your constant? -2. So notice in synthetic division, I don't put any of my x's there. Sometimes I like above my synthetic, I like to like write down what is my highest exponent, like an x squared term, and then I just like say all the things that should be behind it, like there should be an x and there should be a number, because then I don't forget any zeros if I am missing something. Okay, so I like to put that out there. All right, now outside of the synthetic box, we have to figure out what to put there for this divisor, x minus 2, because we're not going to put an x in it. So outside of the synthetic box, I'm going to say this. Use the 0 of the linear factor. So synthetic doesn't work all the time. Synthetic works when you're dividing by something that's linear, meaning it has a degree of 1. It's really easy to find the 0 of that factor. You're just setting x minus 2 equal to 0. Solve for x. So you're really putting x equals positive 2 on the outside. So if you're dividing by x minus something, you put positive on the outside. If you're dividing by x plus something, you put a negative, the opposite, because it's a 0. Okay, so that's the setup. Any questions? Okay, here are the rules to synthetic division. Follow them in this order. Add down and multiply until you get to the end. Repeat. So the first one is add down. This one's always very easy. There is nothing to add. So your leading coefficient just drops. 1. It's outside of the box. Okay. Add down. Multiply. 1 times 2 is 2. That goes inside the box in the next column. Then add down. 2 rules, right? Add down, then multiply. So now 7 plus 2 is 9. Multiply. 9 times 2. 18, that goes inside the box. And add down. I'm at the end of my box, so I don't need to do anything more. If I multiplied, I have nowhere to put it, right? So I just add down and multiply as many times as I can. But you end on an add down. You're at the end of the box. Do those numbers look familiar to you? Yeah. Notice like the 2 and the 18, we saw those numbers in our long division. The 1, the 9, and the 16, those are in our answer. Okay. One reason why in the beginning I like to put x squared x and a number on the top here is, if I think about the fact that I took a quadratic, an x squared, and I divided it by a linear factor x, then everything in the answer goes down by 1. So if this used to be x squared, now this is x. And if this was x, this is now a number. And if this was a number, this is now a remainder. And so all I have to do for my answer is put those things back with their x's, right? Like 1, 9, 16 doesn't mean anything. You have to put the x's back. So it's x plus 9 plus 16 over the divisor x minus 2. And that's the same answer that we got with long division. How nice. Okay, I'm going to do it again with the other one we did. Okay. So if you want to do it like next to that one, or down below, it's totally up to you. Okay, that's the x cubed minus 8x plus 3. Okay, so remember you have 2 lines right here. Above my box, what is my highest exponent in my dividend? X cubed. So this is above my box. This is not in my box. I sometimes like to do this. If I have x cubed as my highest exponent, then I have to have an x squared, then I have to have an x, then I have to have a number. Like I have to have every single term going down. And that way I can make sure that I always have my zeros when I need them. So what's your coefficient to x cubed? 1. X squared? 0. X? Negative 8. Number? 3. What do I put on the outside? Negative 3. Okay. Rules of synthetic. Add down and multiply. remember on the first one, there's never anything to add, so do not be alarmed. You always drop your leading coefficient. Okay, and it goes outside the box. Multiply 1 times negative 3. Negative 3. Add down. 0 plus negative 3 is negative 3. Multiply negative 3 times negative 3. 9. Add down. 1. 1 times negative 3. Negative 3. Ooh, love that. Put a smiley face in my 0 because I love it so much. Makes me so happy. Okay. 0 remainder. Okay. And because I took an x cubed and divided it by an x, now everything is 1 less. So this is x squared, this is x, this is a number, and this is my remainder. So my answer is 1x squared minus 3x plus 1. Same answer, right? Less work, maybe, we could argue. Okay, Carly.
Why is it x squared, not x cubed?
Because you're taking an x cubed, like we took all the x's out so you don't see it. We're taking this x cubed and we're dividing it. We have this negative 3 on the outside, but remember we're dividing it by x plus 3. So a cube divided by an x is an x squared. So everything will always, in those columns, they'll always drop by 1 because you're always dividing by a linear factor. Okay, any other questions? Okay, I'm going to do another one. Just this one is going to be new. Negative x to the 5th minus 3x to the 4th plus 2x squared minus 5x plus 10 divided by x minus 5. Okay. Since this x minus 5 is linear, right, it has a degree of 1, that means it's linear, I can use synthetic. Now I could use long division if I wanted to, but I'm going to use synthetic. Okay. What will my 0 of x minus 5 be? X equals positive 5. So that's the one that goes on the outside, right? Okay, what's my highest exponent in my dividend? X to the 5th. So I have to have an x to the 4th, x cubed, x squared, x, and a number. Ooh, I gotta have a lot of coefficients in there. Put only the coefficients, none of the x's in. In front of x to the 5th is a negative 1, negative 3. Ooh, 0, 2, negative 5, 10. Do you see how easy it would be to skip a 0? How dangerous it could be to skip a 0? Then your add, down, and multiplies won't be the same after that. Okay. So I like to put all my x's at the top and make sure I have all of them. Put the 5 on the outside. Add, down, and multiply. Negative 1. Negative 5. Negative 8, negative 40, negative 40, negative 200, negative 198, negative 396, oh, yeah. Oh, sorry. I was multiplying it by 2, but it's 5, isn't it? Negative. Did I do my other ones? No, I did my other ones right? Okay, what? Negative 990. So that's negative 995. Oh, man. times a negative 5, or sorry, positive 5, negative 4,975, negative 4,965. My God, I didn't do that one by long division? Yeah, I am. And I just have to put these back. Remember, everything will drop by 1. So this will be x to the 4th, x cubed, x squared, x, a number, and then this one's my remainder. So it's negative x to the 4th minus 8x cubed minus 40x squared minus 198x minus 995 minus 4,965 all over x, minus 5. Okay. So you got some problems to practice tonight. Follow the directions in the textbook. If it says long division or synthetic division, do whatever it asks. You can use a calculator on those problems like this one where it came out really big. Okay. Notice that like this last example, I wouldn't be able to do synthetic because it's being divided by a quadratic. So I would have to do long division. Okay, is it 12:32?
Yes.
You are dismissed.